This is our video on manipulating these exponential models we've been working with. I'm going to walk you through the first two questions just to get an idea, and then the other three are things that we've either modeled in class or I've done on this video. All right, so Daniel goes to the bank and withdraws all $80,000 that is in his account. For the last 7 years, he's had his original investment compounded quarterly at 6%. What was his original investment? So generally, we have our amount at time t is our amount initially times 1 plus my rate over the compounding period raised to the compounding period times the time in years. So now we know 80,000 that was in his account after 7 years is going to be A of 7. So that's going to be our amount in the future. We want to find his original investment. So now the initial investment is the unknown. So this is X times 1 plus, I know my rate was 6%, so that's 0.06. We're compounding quarterly, 4 quarters in a year, raised to the 4 times 7, because 7 years has gone by. So A of 7 was 80,000, so the T is 7. So now we just have a very simple equation to solve. We have 80,000 equals X times, well, now I just have to figure out, well, I don't even have to figure it out. I can just write, I have 1 plus 0.06 over 4 to the 28th power. And I have X times a number. So yeah, you could go plug this number into your calculator and get it. But here's what I'm going to do. I'm just going to divide by 1 plus 0.06 over 4 to the 28th power. I don't really care what that number is, because ultimately I'm going to divide by it. And I can do that on my calculator pretty easily. And here's how you can do it. You can set up a fraction on your calculator. So you can go alpha y equals enter, 80,000. So I'm going to move this up a little bit to get the 0. 80,000 divided by 1 plus 0.06 divided by 4 raised to the 28th. And this will give me my initial investment. So X is, let's say we'll round that to the nearest dollar. That's going to be $52,728. That would be my initial investment. Kind of a strange number, but perhaps he had an account and he reinvested the money that he had in that account. All right, next one is the second one I'm going to model for you, just so you get an idea. So Mark deposits $35,000 in a savings account that is compounded monthly. After 4 years, he retrieves the $100,000 in the account. What was the interest rate? So we can also solve for other things. So this is my initial deposit, $35,000, times 1 plus, well, I don't know the interest rate, so I want to leave that blank. I do know it was compounded monthly, so that's 12. And now I have raising this to the 12 times, well, I know my time was 4. And that has to equal $100,000. So now our goal now at this point is to solve for R. So I have to unravel this. R is kind of stuck here. Just to get an idea, this would be 100,000 equals 35,000 times 1 plus R over 12 to the 48th power. And I can divide by 35,000. Because ultimately I want to get to this R. I've got to unravel everything that's bothering the parentheses first. So now I get, on this side, I get 1 plus R to the 12, R over 12 to the 48 equals 100,000 divided by 35,000. So I can type that in, divided by 35,000. And that equals 2.857142857. So here's what I'm going to do. I'm just going to write it. I'm going to press math, enter, enter on my calculator. I'm just going to write it as a simplified fraction. I'm going to write it as 20 over 7. Because otherwise I got to either find the repetition in that decimal or truncate it. I don't want to do that till the end of the problem. Okay, so now I have 20 over 7 equals 1 plus R over 12 to the 48th power. Well, I want to undo something to the 48th power. 2 ways you could do that. I could take the 48th root on both sides. Alternatively, so an alternative method to this, to undo that, this is an alternative, is I could think of 48 as 48 over 1 and raise both sides to the 1 over 48th power. As we know, raising something to the 1/48th power is the same thing as taking the 48th root of something. So I don't really, it doesn't matter how you put that in your calculator. I happen to think a little easier is to do 20/7 raised to the 1/48, just so you don't, if you forgot where the root key is, you can do it this way. If you remember where the root key is, it's math, and if you press 5, so actually before you do that, math 5 will give you the root key, but you have to put the 48th root in first, and then math 5, and then it'll become the 48th root of 20/7, and you'll get the same thing. So here we get this ugly number. I'm going to write out the whole thing. So it's 1.022112224. 1.022112244 has to equal 1 plus r over 12. Notice I did not round because I want to make sure I'm accurate here. So now I have to get r by itself. So I want to subtract 1 from both sides. And we shouldn't be shocked to see that the 1's cancel. And we get 0.022112244. I feel like I'm missing a 2. Yep, sorry, this 4 here should be a 2. This should be a 2. Not a big deal because it's so far out in the decimals. Equals r over 12. And then I'm going to be multiplying both sides by 12 to get the yearly rate. This 0.022 would actually be the monthly growth. So I'm going to take this, I'm going to subtract 1, right, and then multiply that by 12, and I'm going to get my monthly rate. And sorry, I will get my yearly rate of 0.2653, which is 26.53%. Now, as I'm doing this problem, we did it correctly, but I would be very skeptical of Mark's claim, simply because in a savings account to get 26% a year is pretty crazy. So this is correct, but I would definitely be skeptical of this claim that Mark's making. So if I were kind of asking Mark, what's going on with your life here, I would be very skeptical of this claim. All right, so these problems will be on the video, so you can watch them again, obviously. And there are 3 similar problems for you guys to do in this packet. Thanks.